Alright guys, here's sort of the last set of problems on the page, and they should be the hardest ones, I think. I don't know, maybe they're easy. They're asking you to do a little more than the other ones. The other was just getting you to sort of play with the equation and understand it. So everything up until this point was just to get you familiar with and comfortable with, that equation for a circle. Here's ones that ask you to think a little more and do a little more. I'm giving you the center here, so you know H and K are given on there. I'm giving you a second point. If you have the center and another point, you're going to have to work to find the radius. Think about how you find the radius here. Well, you find a radius by finding the distance from the center to another point. So you're going to have to, so the first step of this is identifying the radius. The second step is going, oh man, I'm going to have to find the distance from 3, 1 to negative 1, 2. And I would just do that quickly with the distance formula. From 3 to 1, negative 1 is 4 units away, so 4 squared. And from 1 to 2 is only 1 unit away. So you got 4 squared plus 1 squared. That's 16 plus 1, that's 17. Now, the radius is not 17, the radius is the square root of 17, which would be obvious if you graphed this. So this is sort of the easy part. Probably everybody gets this because it's just plugging these two into the equation. The radius comes from finding distance again, like I said. That's where that rad 17 comes from. So this equation, a lot of people will write it incorrectly with that because they'll forget the square root sign on there. Oops. Don't forget the square. Oh, sorry. I take it back. They'll write it correct. They'll write it with the rad sign in here. Remember that in the actual equation, this number has been squared. So the radius is rad 17. When I square it, rad 17 times rad 17 is 17. Hopefully I didn't make a mess out of that. I got the little clock up here. If I was in class, I would let you have minutes to just work on this and think through this. Same idea on this one. I'm giving you 2 points that are the diameter. And of course, this is sort of combining two things that you already know. If you know the 2 points that are on the diameter, endpoints of the diameter, you can find the middle of those, and that'll give you the center of the circle. So what's exactly, just to do it, coordinate by coordinate, you use the midpoint formula, or you could just use logic. What's between 4 and negative 4? And then you go, oh, that's 0. There's the x-coordinate of the center. What's between negative 2 and 0? And you go, oh, that's negative 1. So I would think the first thing you probably do, I guess I'm doing it another way on the screen here, is find the center, because that's kind of the easier part. The second thing, which you saw I probably just did right there, I tried to find the distance, and somehow I got 68. And just to check that, let's see. Using distance, from 4 to negative 4 is 8. So 8 squared, that's 64. And from 2 to 0, or negative 2 to 0 is just 2 units. You square that, you get 4. Yeah, 64 plus 4 is 68. So I put D for, not for distance, for diameter. The diameter is rad 68. Half of that would be your radius. And of course, all of you are experts at simplifying radicals. Factors of 68. If I cut it in half, I get 34, which is another even number. I cut that in half again, which means 4 goes into this. 4 goes into that 17 times. So there's my center, which we talked about a minute ago. It's the average of the x's and the average of the y's, just finding a number between negative 4 and 4 and between negative 2 and 0. Put the whole thing together now. We've realized we can factor that to 2 rad 17. And, not by coincidence here. By coincidence, sorry. The radius for this one ends up being the same thing. The diameter is 2 rad 17, which means the radius is just rad 17. And if I square it, I get that one. So if that didn't make any sense, maybe rewind that, replay that in your set. I don't know that I talked through that very well, but it's not a hard problem, but it requires 3 or 4 levels of thinking. You've got to understand how to find the midpoint and what that means. You've got to understand how to find distance or diameter, and then realize you have to simplify that and cut it in half. And then you got to understand the basics of the equation on there. So there's your answer right there. The last one should be the trickiest one. This is going to come back to something you did a very, very long time ago. Many, many moons ago, I gave you problems where I said, find a point equidistant from 3 other points. Find a point equidistant from the 3 other points. And you had to use perpendicular bisectors to do that. Well, if you were to quickly think of a graph of this, which is apparently what I have that little triangle there for, you'll notice very nicely, very kindly, I gave you ones with common y coordinates and common x coordinates. which means like from this point to this point is just a vertical line. You know, from negative 5.1 to negative 5.7. That's just a vertical line that goes up 6 units. There's a hint. It goes up 6 units. It goes up 6 units. That's going to be 6 units long. From negative 5.7 to 2.7, the y-coordinate doesn't change, so it's going to be flat. It's only going across 7 units from negative 5 to positive 2. So it's going across 7 units. So that's sort of the trick on this thing. Let's see if I did it that way. I threw a sort of a quick sketch of a graph on here, not to scale certainly. And of course I changed my coordinates up here, so that's a mistake I might have to go back and change. I don't know if it throws me off at all. This is 2.7 I think on your paper, and it should be 2.7 here, so we'll see if my calculations are wrong or not. Well, there you have it though. This is 6 units long, and I wouldn't use distance formula. I would just go from 1 to 7. That's 6. From negative 5 to 2, that should be a 2 on there, that's 7 units. So you've got 6, you've got 7, you could find this hypotenuse on there, and you could find the midpoint of that. There might be an easier way to do this. As I mentioned before, if you perpendicularly bisect this side and perpendicularly bisect the top side, you can find that point. And as many of you probably remember, it's the midpoint of the hypotenuse for any right triangle. So let's see if my numbers are right on here. Halfway between 7 and 1 is 4. So this is going to be negative 5, 4 is right here. That's negative 5, 4. And I'm going to go straight across from that. And I would go right between these 2 points. Again, it should be negative 5. And that's why I had the 3 there. Maybe it's nicer to use my numbers here. If you use the 2 on your paper, you're going to get a fraction. You know, it's going to be negative 1.5. Or negative 0.5. I think I was trying to avoid that. Yeah. So I threw this 3 in here. Maybe I should have changed it on your paper. If you want to make it life easier for yourself, change this 2 to a 3. And the reason for that is it keeps this number for this length an even number, which if you cut that in half, this is now 8. If I cut that in half, it means I'm at an integer value on here. I just wanted to make the problem a little easier. And I forgot to update my paper when before I printed this out. So if you want to make it easier, make this a 3. And understand that this distance is going to be 8 units long. This is not drawn to scale. But it's from negative 5 to positive 3, which is 8 units. I cut that in half, I'm going 4 units away. And of course, if I go 4 units over, that puts me at negative 1 in terms of lining up my x-coordinate on there. So this is definitely the trickiest problem of the batch here. So that gave me my center of my circle. That was, like I said, I kind of threw this in here just to connect with something you did way back in Chapter 5. So you understand that's why this circle chapter is at the end of the year. Kind of put it all together. So if you didn't understand all the other gobbledygook, that's okay. Write the equation of that circle now. You should be able to do it now. I've basically given you the center. So you're going to go x plus 1 and y minus 4 and have those quantities squared and come up with your radius. Radius comes from distance on there. So I don't know why this particular slide's coming up. Let's see what I got here. Oh, there's the homework. You can't see it, of course. I don't know if it's on Schoology yet, but it will be eventually. So try that out. If you have time in class, it's a good time to try it. Ask Mr. Snyder questions if you have questions. This is due on Tuesday, and I'll be back on Tuesday to kick this up a notch, and we'll do some more stuff with circle equations. Have a good day.